Hi everyone, welcome back to weekly contest analysis. Let us discuss the first problem. So the first problem is valid triangle. So problem says that we'll be given three sticks. So we'll be given three sticks. The first stick has the length A, second one has the length B, and the third one has the length C. And we need to check whether it is possible to make a triangle with a positive area using these three sticks or not. So basically we have been given three sides of the triangle and we have to determine whether the triangle will be possible or not. If we have to do this, so basically there is one concept, that is, if I have been given three sides, let's say if I have been given three sides A, B, C, and if I want to make a triangle out of them, then the concept is that sum of any two sides, okay, sum of any two sides should be greater than the third side, should be greater than the third side. Okay, so what does this mean? Let's say if I'm having side A plus B, if I'm adding these two sides, so it should be greater than C. If I'm adding, let's say, B plus C, so it should be greater than A. If I'm adding what? If I'm adding C plus A, so it should be greater than what? It should be greater than B. So this is what they expect, that if you have to make a triangle, so sum of any two sides should be greater than the third side. Now, do you need to check each and every condition? Because normally a person might do what? He or she might end up checking all the three conditions. But the thing is that you don't need to check all these three equations. The thing is that if sum of any two sides needs to be greater than the third side, so you can say that if sum of the two smaller sides, okay, let us assume that A is the smallest. Let's say the side A is having the smallest height, okay, then B is let's say medium, and then C is the largest, okay, C is the largest side. Now in this case what will happen, if you have to check, so if the sum of the two smaller side, if it is greater than the third side, then the triangle is always possible. Okay, so what we can do here is we can basically put the elements in an array and then we can sort the array of three sides. Then after that, if the ARR of 0 plus what, plus ARR of 1, if it is what, if it is greater than ARR of 2, if the sum of two smaller side is greater than the third side, then all the other combinations would obviously follow. Because let us assume, if you will see here, if ARR of 0 is the smallest side, so if the smallest side plus medium side is greater than the largest side, so if you will do what, if you will do ARR of 0 plus what, ARR of 0 plus ARR of 2, so it is always going to be greater than ARR of 1. So you can only check one condition. So that is the sum of two smaller side. If it is greater than the third side, then a triangle will always be possible. So what we can do here is, let's check the output is wanted in yes and no format. Okay, so let's do one thing. Let's try and implement this. So what we'll do here is, first of all, we'll declare an array. Okay, we'll place all the three elements A, B, C inside it. So let's say we'll put A, then B, and then C. Now after that, we'll sort this array. So we'll sort what, ARR comma ARR plus 3. So all the three elements will get sorted, and if the ARR of 0 plus what, plus the ARR of 1, if it is greater than ARR of 2, if the sum of two smaller side is greater than the third side, then the triangle will always be possible and we can simply return yes here. Okay, otherwise if it is not possible, if it is not greater, then we'll simply do what, we'll simply return false. So let's try and return false here. So yeah, otherwise what we'll do is, if the possibility is there to make a triangle, if the sum of the two smaller side is greater than the third one, then we'll return yes, otherwise we'll return no. So let's now try and compile this code. So you can see it is getting compiled. Let's submit this code as well. It should get accepted, and the code gets accepted. So the time complexity for our approach will be order of 1, and space would also be order of 1, because we are only doing the iteration on three elements. Thank you for watching this video. So let's move to the next problem. So now let us discuss the next problem, that is super palindrome. So the problem says that you are given two integers L and R, and you have to count how many super palindrome numbers are there in the range L to R. Now what is a super palindrome? Super palindrome is basically a number which is a perfect square, as well as it is palindrome in its decimal representation. For example, let's say if I have been given what, let's say if I have been given L value as 100 and I've been given the R value as what, 1000. Now in this range I have to find all the super palindromes. So let us understand that, suppose if I take the starting guy as what, like if I have been given L as 100, Okay, so I will take under root of L as the starting point. Okay, so in this case, when I'll take under root of L, what will I get? I'll get 10. So I'll say that this is the element that I have, that I'm starting from, that is 10. And basically, if I have got 10, so what is the square? Like 10 square will be how much? 100. So that is why this element is going to be in this range. Now, when I have got 100, right? So is the element 100, this element 100, it is obviously a perfect square, right? Because 10 into 10 is equal to 100, because the question says that the element should be perfect square number. 100 is a perfect square, obviously, but is it a palindrome? No, 100 is not a palindrome. Then after that, I'll update the start value, and it will become 11. Now when the start becomes 11, right, then I'll have the element 121. You can see that 121 is lying in this range. Okay, so 121 is obviously a palindrome, so it will be counted. So count will increase by 1. Then after that, the next element will be 12. Now since the next element is 12, so 12 is what? 12 is basically 144. Okay, 144 is not a palindrome. 100 was also not a palindrome. If you will check 13, so 13 will be what? 13 will be, I guess, 169. So it is not a palindrome. So if you will see in this particular range, if you will see in this particular range, so first number is 121, next is 484. So you can see that after this, when I'll write 14, so 14 is what? 196. It is also not going to be a palindrome. Then 15 will be what? 15, I guess, will be nothing but let's multiply 15. So 25, then 1 5, so 1 7, 5 5 is 25, 275. Yeah, so 225. This is also not a palindrome. Okay, then when you will try for 16, so I guess 16 will also not be, but later on 484 will be a palindrome. Okay, so 16 will also not be a palindrome. So this is how you will keep on checking. Okay, basically you can make your starting point, let's say, as under root of L. If it is decimal, then you can take the C value, and then after that, for that particular current start value that you are at, you will do the square of it, because when you do the square of it, so it will be obviously a perfect square. For example, 100 is a perfect square, 121 is a perfect square, 144 is a perfect square, right? So in this particular scenario, whenever, like, you already are generating perfect squares, now your responsibility is to check that the numbers that you are generating, whether they are uh, palindromes or not. So you can basically enter them into the string and then check whether the element itself and the reverse are same or not. If they are, then you will count. For example, if you will take the scenario when you have got what? When you have got the L value as 1. Suppose your L value was 1 and R value was 10. So if this is the scenario, so in that case, you will take the starting point as, let's say, under root of L. So that will be basically 1. Now 1 into 1 is what? Like 1 into 1 is basically 1. So you can count it as a palindrome. Then after that, 2. So 2 into 2 will be 4. It is also a palindrome, because it reads the same from left and right both. Then 3 into 3 will be how much? 9. So it is also a palindrome. It will be counted. Then 4 will be out. 4 into 4 will be 16, which will be outside the range. So it will not be considered. So you can see that total 3 numbers are there in the range L to R that are super palindrome, because they are palindromes as well as they are perfect numbers, perfect squares, right? So let's try and write the code for this particular approach here. What we will do here is, first of all, we will declare a start variable. Let's say the start is equal to what? Let's say ceil of the square root of L. Okay, this will be my starting point. Then I'll also take a counter. Let's say count initially is equal to 0. Then we'll say that while the start into the start. Okay, if it is less than equal to R, right range, then I'll keep on doing my job. Okay, now the current string that I'll have is what? Let's say I'll mark the string as st is equal to nothing but to string start into start. So whatever square number I'm having, first of all I'll insert it into a string, because start is obviously a perfect square. Now I need to check whether it is palindrome or not. So I can easily check it by putting it into a string. So I'll put it into the string and I'll check that if the st is equal to what? Is equal to the reverse. So I'll write a string here, okay, and in this string I'll pass the reverse. So I'll pass st dot r begin comma st dot rn. So I could have done it using the normal approach also, checking up whether a string is palindrome or not, but I'm using inbuilt function here to check. But if you want, you can do it manually on your own as well, okay, by applying the two pointer philosophy or any other approach. Okay, so if the number, obviously the current number start into start is a perfect square. Now if it is a palindrome as well, so it is a super palindrome number for me. So I'll count it. So I'll mark the count plus plus. And after this, every time I'll update the start. So start will always move by 1. Okay. And at the end, we'll simply return the counter here. So let's try and compile this code to check if it is working fine or not. It should work on the samples. Let's see what happens. So it works fine on the samples. Let's submit this code as well. So you can clearly see that my code is able to pass all the test cases. Now talking about one more criteria, that why did I take the seal of the under root of L? Because suppose that if you have got something like this, let's say my L value is what? Let's say 110. Now if my L value is 110, then my start will be what? It will be starting from under root of L. Under root of L will be 10 point something. Now since it is 10 point something, so I cannot take 10. I have to start taking from 11, because if I take L value as 11, that is the seal value, then 11 into 11 will be 121. So 121 will start coming under this range. Okay, from 110 onwards. 100 will not come. So that's why we need to take the seal also. So I hope you have understood this problem, and let's move to the next problem now. So let us discuss the next problem, that is string replacement. The problem says that you are given a string S which consists of only the characters A and B. In one operation, what you can do is you can replace AB with BBA. So wherever you find the substring AB, you can replace it with BBA, and you have to find the minimum number of operations such that there is no AB substring in the string S remaining. And since the answer can be large, so you have to always take the modulus with 10 to the power 9 plus 7 while counting the number of operations. So if you will see the first test case, let's say you have got something like BAB. So in this case, you can observe that this particular expression is AB. This is the substring AB. Now instead of AB, I can replace it as what? If I can say that I can take one move here, right? Then I can replace it with BBA. So now I have B here, and I can replace AB with what? BBA, right? So this is how I will get this string. And in this particular string, you can see that I am not getting any further AB substrings. So the total number of moves that I have taken is nothing but 1 here. Now how can I solve it? So basically my goal will be that I'll start converting all the ABs into BBA, such that by the end of the process there is no AB remaining in the string. So what we can do is we can apply the approach that we will not want any AB till the very end of the string, right? So we can start from the right side, and let's say that we have got something like AAB here. Suppose we have got AAB. This is the string that we have. Now in this case, what we can do is we can always maintain a count of B. So let's say initially the count of B will be 0, and our answer variable will also be 0. Now what will happen when I reach the guy B? Then since it is character B, so I can say that I'm having character B. So in future it can potentially make one AB substring. So that's why I'll increase the count of B as 1. Then after that, the next time I'll reach A. So the moment I reach A, then we can observe that whatever B's we had so far, right, we can add them into our answer. So we had the count of B is 1. So the answer will get updated with the count of B. So answer will become what? 1. Then what happens? Now the string looks like what? It is A, then what? BBA. Because of this AB, now after replacing it, I'm getting BBA. So you can see that whatever B's I had, now the number of B's gets doubled. Okay. So that's why you'll increase the count of B's by 2 because of this A. Now the substring AB was complete. So since the substring AB is complete, so you can say that now the number of B's will get doubled, because earlier if you were having 1 B, so now you are having 2 B's. So now since you are having 2 B's, so that is why next time when you move to the character that is A, then what will happen? When you move to this character A, then you will make BBA, right? So when you move to this A, you will add the count of B's. So how many B's are there? 2. So the count will update by 2. So total, so the answer will update by 2, and 1 plus 2 will be how much? It will be 3. Why? Because if you see, first of all, we did one operation of AB here, then another operation of AB if we do here, then the string will become BBA, and then what? BA, because AB will be replaced with what? BBA. Now because of this, you have completed one more AB sequence, that is substring. So you will have the string as BB, BBA, because AB will replace with BBA, then A. So you can see that 2 operations were made because of this. So that's why whatever was the count of B at that point, if I had this much, if I had this A, so total number of ABs that I would be able to make from here is nothing but whatever is the count of B here, okay, on the right side. So let's take one more test case here. Let's say that if we had something like this, if we had A and then B. Suppose if we had this, or let's take another easier test case. Let's say if we had something like AB and AB. If we have this particular test case, then initially what is going to happen? Initially my count of B is going to be nothing but 0, and I'll mark my answer as 0 as well. Now when I reach B, so I'll say that I'll increase the count of B by 1. Now when I reach A, so whatever B's are there on my right, I can make AB substrings. So that's why answer will get updated with the count. So answer will get updated with 1. Now I have got AB and then what? BBA. Okay, now after this, what will happen here? Now after this, you will observe that when you will move forward, so since you had a B here, so now you'll update the number of B's as how much? Since AB was completed, so now earlier you had one B on the right side, now you have two B's on the right side. So you'll say that count will increase to 2, and then what will happen is next time you will be at this character, because you'll always iterate, and right now you were at this A, now you'll be at this B, so you will be at this guy. Since it is B, so you'll increase the count of B by 1, so it will become 3 here, right? Now after this, when you reach this A, so when you reach this A, it means that you can make AB substrings. So now instead of this AB, what will happen? You will have BBA, then you have got BBA here, right? So you can see that answer, since you reach A, so whatever is the count of B, you will update your answer with that. So answer will get updated by 3 more. So answer will be 4 total. Why? Because one operation you have already done, that is when you had found the very first AB pair here. So one operation has been done here. Second operation of AB has been done here. Next time when you have got this AB, then this will be BB, and then what? This would be BBA again, and then BA. So now again AB is there, so again one more operation will be done. So this will be basically BBA part. Okay, and then rest of the B's would follow as the same. So basically you can see that total 3 operations were added, because with respect to this particular A, 3 B's were there on the right side. So these all 3 B's got converted, right? So you can see that this B got converted here, then this particular B later on, and then this particular B later on as well. So that is how we are solving it. So every time whenever you are at a particular character B, so then you will increase your count of B. But if you reach a character A, so if you are at the character A, then you will say that because of this character A, the AB substrings are going to get completed, and whatever number of B's are there on the on the right side, they will get doubled, because instead of AB I'm replacing with BBA. So it will have a cascading effect, it will have an exponential impact. So the number of B's will always get doubled, right? So that's why you can see that later on when I reach this A, so far I had 3 B's. So this means that I can make 3 more pairs of AB. So that's why the answer got updated by 3, and the answer finally was 4. So this is how we can do it. Let us implement the code as well. You can try it on other test cases like AAA-B as well. Then you can understand it better. Basically, as the test case keeps on increasing, so you'll be able to observe that whenever we reach a, so the number of B's need to get doubled. Why? Because it is having exponential impact or cascading effect. Okay. So let's say that if we have this string, so first of all, what we need to do here is we need to count the number of B's. So initially we'll say that the count of the number of B's will be nothing but 0. Then we'll say that initially our answer is going to be what? Initially our answer is going to be 0. Then we'll say that int mod is going to be what? Let's say 1e9 plus 7, because we have to take the mod with 10 to the power 9 plus 7. After that we'll do what? We'll iterate. So let's do one thing. Let's take the variables in long data type only, so that we don't see any overflows. All right. Now after that we'll start iterating from the end point. So I starts from what? S dot size minus 1, because we are always going to iterate from the rightmost side. The reason is that we don't want any AB till the rightmost end. So we can decompose the string one by one from right to left. So then what will happen? After that we'll iterate till the starting. So I is greater equal to 0, then I minus minus. Now what will happen here is, if suppose that the ith character is equal to B. So if the ith character is B, then this means that you have got another B, so you need to increase your count of B's. Otherwise what you need to do is, you need to say that since you have got A, otherwise in the else case you have got A. So if you have got A, so whatever B's you are having on the right side, they will make the pairs of AB one by one. So then you will increase the answer by count of b, and you will take the modulus with mod. Okay, then after that what you will do is you will say that count of b will be what? It will get doubled, because every time you are having ab, so you are getting ab and you will replace it with bba. So every time the number of b's on the right side will get doubled, and it will be a cascading effect. So then count of b will be what? Count of b is equal to count of b plus the count of b, that is you are doubling up. Since I want to do the modulus, that is why I'm using the addition operation here, modulus with mod, and then after this we can return the answer simply at the end. So let's try and do that, and hopefully it should work fine on the samples. Okay, it's working fine. Let's try and submit this code as well. Okay, so it does get accepted. The time complexity would be order of n, because we are just iterating throughout the string, and the space is order of 1. I hope you have understood this problem as well. Now let us discuss the problem make array 0. Let's talk about the feedback of this problem first of all. To be honest, it was a hard problem and it requires some prerequisite. For example, for this problem you should have some idea about binary search on answer. You should have solved some problems like minimizing the maximum allocation of pages, Coco eating bananas, and many other problems that are based on binary search on answer, like capacity to ship within D days as well. So if you have basic idea about binary search on answer, then you can get intuition for this problem. Okay, now in this problem it says that you will be given a positive integer array, so every element will be positive, you can say, and there are n elements inside the array. You have been given two integers, that is p and q. Now in one operation what you can do is you can select any element from the array. So in one operation what you can do, if you're making one operation, choose any element and subtract that element with p. Okay, so basically suppose you have got an array like this, then what you can do is you can choose any particular element. Let's say you choose this element, then you can subtract this element with p. So assuming that you have chosen the ith element, so you will so the ith element value will be now what? A of I minus p. Okay, so it will decrease by p, and rest of the other elements you have to subtract by q. Okay, rest of the other elements would be subtracted by q. That is what the problem says. It says decrease a particular chosen element in one move by p, and the other remaining elements would be subtracted by q. Okay, would be reduced by q. So if any elements become negative, then it can be replaced with 0. So the moment the element starts becoming negative, so you can replace it with 0. And what you have to do is you have to return the minimum number of operations that are required to make all the elements of the array equal to 0. So basically your target is to do what? Your target is to make the sum either as 0 directly, like a particular element you have to either make it as 0 or you have to make it negative. Because if you make it negative, then you can assume it to be 0, right? Now how can we do this? So basically you can observe one thing, that what is the minimum number of moves that will be required. So the minimum number of moves, if you'll observe, the lowest number of moves that I might require would be how much? The lowest number of moves that I'll require is nothing but, let's say, 0. Okay, I might not have to do any operations and still my all the elements might become 0, but although that might not happen, but in general it's best to choose low as 0 or 1. Now what will be the highest number of operations that I might have to perform? So suppose that if p is a special operation, because I'm having one operation p, that is I can choose an element, okay, and I can subtract it with p, and rest of the other elements I have to subtract with q. So basically I have to check that if suppose that I am doing the special operation only, so how much time would I take? Like in this case, in fact, if you will see here, so since the array elements have been given from 1 to 10 to the power 5, so I can say that the maximum, the highest value can be, let's say, 10 to the power 5. Okay, the highest number of operations that I can perform is, let's say, 10 to the power 5, assuming that p and q are given as 1 and all the elements are, let's say, 10 to the power 5. Then this might be the highest that I might need. Okay, now in this case, let's say I am at a particular mid value. Okay, now from this low and high I have chosen a mid. Now once I choose a mid, so mid number of operations, basically mid indicates the mid number of operations. Mid number of operations. Now if in mid number of operations, and what does one operation mean? One operation means that I am subtracting one particular element with the p value and other element with the q values. So if in mid number of operations I am able to do my job, so there will be two answers. Either I'll be able to do either I'll be able to reduce all the elements to 0 or maybe negative in mid number of operations, or I might not be able to do so. So if I am able to reduce all the array elements to 0 in mid number of operations, then I can say that I'll store that as my answer. I'll say that in that many mid operations I can do my job, but I'll still look for something lesser. I'll look for some smaller answer. So that is why I'll search on the left side of my search space. So my high will become what? Mid minus 1. Because if mid satisfies the criteria, then I'll say that yes, mid is definitely one of the answers, but can I get something smaller? So let's search on the left side. Otherwise, if the current mid cannot do the job for me, okay, if the current mid that I have, if it is not if in the mid number of operations I cannot make the all the array elements as 0, then I need to search on the right side. So I'll do what? I'll update my low as what? I'll update my low as nothing but you can say mid plus 1. That is, I need to search on the right side, because if mid does not satisfy, mid minus 1, mid minus 2 will also not satisfy. So we need to search on the right side. So this is one basic structure of binary search. But when we'll write our check function, that whether in the mid number of operations we are able to do our task or not, then also we have to check a few things. Because if we have chosen that in total mid number of operations, if we are able to do our task or not, so then we will talk about the check function as well. But let's write this much boilerplate for the binary search on answer. So what will happen here is, first of all, in this particular scenario, first of all, I'll say that I need to declare low value and high value. So let's say initially I'll mark my low as 0, and let's say I can mark my high as what? Something like let's say 10 to the power 5. Okay. Then after that, for safety, you can take it as 10 to the power 6 also, but I guess 10 to the power 5 will work as well. Okay. Then we can declare one mid variable. Then after this, what we will do is we'll also need an answer variable. So let's say we can declare int, let's say answer. Initially, let's mark it as 0. Then we'll say that while the low value is less than equal to the high. So while the low and high are not crossing, then we'll calculate the mid, and mid will be how much? Mid will be nothing but you can say low plus high minus low by 2. So basically, once I find my midpoint, then what will I do? I'll write a check function. So I'll write that if I'm applying a check on this mid, that in mid number of operations, whether I can do my job or not. So in that case, I'll pass n, I'll pass the array, I'll pass the p value, and I'll pass the q value. And if it returns me a true, that in mid number of operations, the task is possible, and I can make all the array elements as 0, then I'll say that I'll store this mid answer and I'll look for something lesser, something better. So then I'll mark my high as what, guys? I'll mark my high as mid minus 1. Okay. Otherwise, what I'll do, guys, is I will update my low as mid plus 1. Okay. Now, after the traversal will be over, after binary search is over, then I can simply return what? I can simply return my answer. Now the thing is that how do we write our check function? Because when we are writing our check function, so we need to make the array elements as what? 0. So let's write the check function and see what are the challenges that we'll observe. Okay. So let's say we have written a Boolean check function here. Okay. And in this check function, I am passing what? I'm passing that in mid number of operations, if I'm going to do my job, then I'll pass n value, then I'll pass what? I'll pass the array. So let us pass vector int ampersand arr. Then after that, I'll pass int p. Then after that, I'll pass int q as well. Okay. Now you have to observe one thing. Okay. I need to write bool here because in C++ we have bool. Right. Now after this, if I am trying to do my job in mid number of operations, so how can I try it? So basically for every element as well, let's say if I am at a particular element, so before that some operations might have already been done. Whenever I come to a particular element, let's say if I come at the ith element, okay, if I'm at the ith element, if I'm writing my check function, so I have been given certain total number of operations, correct? Now if I am at a particular element, so before that element certain operations might have already been performed. Okay, so if suppose that p number, like let's say that x number of operations have already been performed. Okay, whenever I come to the ith index, x operation have already been performed, then you can say that the ith element will be what? Now the ith element will be nothing but array of I minus q into x, because suppose that if x operations have already been performed, if assuming that x operations have been taken so far, when I come to the ith element, I have already performed x operations in order to make all the elements before the ith element as 0, then I'll say that so far if I have taken x operations, so my ARR of I, this particular element, should be subtracted with q into x, because if I perform one operation, then ith element should get subtracted by q. Every element should get subtracted by q except one of the elements, that is being subtracted by p. So since before coming to this ith index, I have made x operation, suppose, then the new value of the ith element will be ARR of I minus q minus x. Now this will be the remaining value that I want to make as 0 for this particular ith element. Okay, and I will check that what is the minimum number of operations in which I can make this updated value ARR of I minus q into x as 0. So for that I can also write a binary search. Okay, so what I'll do here is, first of all, I can say that let's say I can write that how many operations I have done so far. So I can take a, let's say, done variable, or let's say done operation variable. Initially I can mark it as 0. This will indicate what? This will indicate that how many operation when I come to the ith element. So when I come to the ith element, how many operations I have performed before the ith element, in order to make all the elements from index I to I minus 1 as 0 or negative, you can say, right? So now what I'll do is I'll iterate. So let's say int I starts from 0, I is lesser than what? N. Then we'll do I plus plus. Now my current element will be what? My, if you will see here, so basically the requirement that I have, the number of steps that I need, or the number of moves that I need in order to make this particular element as 0. So basically for that I can write a function, let's say make 0. Okay, so basically I want to make the ith element as 0. Now when I come to this ith element, so already before this, when I come to this ith element, certain operations have been already performed. So that many times q must have been subtracted from the ith element. So basically you will say that ith element will be now what? ARR of I minus q into the number of operations that you have done so far. Now this is the value of the ith element that you want to make as 0, because already its value was originally it was ARR of I. But so far you have done certain number of operations from index 0 till I minus 1. You have made those elements as 0. So assuming that you have done this much operations, so every time you must have, you will do an operation, other elements will get subtracted by q. So similarly this particular element will also get subtracted by q. How many times? The number of times this operation has been done. So that is q into the number of operations done. So ARR of I will be what? ARR of I minus q into the number of operations done. So this is the value of the updated ith element that I want to reduce to 0. Okay, now if I want to reduce to 0, so I'll say that suppose if I had mid number of operations that I could perform. So how many operations are remaining? If mid number of operations was allowed to me for this particular scenario, so far whatever operations I have done, right, I'll subtract from them. This will give me the remaining number of operations that I can perform on this iteration. Suppose that my mid value was 10, and so far I have performed 6 operations. So now I have 4 more operations remaining. Okay, so I'll say that I have 4 more operations remaining, and I can use them in order to make this remaining element as 0. Okay, if I want to use all of them, I'll use, but I'll try to use the minimum. Okay, I'll try to find the least number of operations that are required to make ARR of I minus q into operations done as 0. So that's why I'll pass the mid minus done value, because mid is the total number of operations for this particular iteration that I'm allowing. Now from that I'm subtracting the operations done so far in this array, right? So that will give me the remaining number of operations that I'm allowed. And if I take more than the remaining number of operations, so that is not allowed. So in that case I'll say that the procedure is not cannot be done in mid number of operations. So basically so far if I want to do the task in total mid operations, and so far I have done these many operations, so these are the remaining operations, that is mid minus done operations. Okay, now after that I can pass what? I can pass the p value as well, and I can pass the q value, right? Now after this I have to check, suppose that if I am not able to do my job, if suppose that whatever number of operations were remaining, in those operations I couldn't make this ith element as 0. If I couldn't make this ith element as 0, so let's say my moves will return -1. If it returns -1, it will indicate that I was not able to make this particular ith element as 0 in the remaining number of moves. In that case, I'll return what? I'll return false, indicating that it is not possible. Otherwise, suppose it was possible, so I'll say that the number of done operations will increase by the number of moves that I have taken in order to make this particular element as 0. Okay. Then after this, what you will do is, in the end, if you were able to do your job, you were able to make the array, all the elements of the array as 0 by taking certain number of operations which were under control, because you never took more than the required number of operations. Then you will do what? You will return true from it. Okay. Now we need to write a binary search function again, because if this is the remaining value of the ith element, so ARR of I minus q into done operation, this is the value that I want to make as 0, and I want to take the minimum number of operations for this. So that's why make 0 function will also be a binary search function, because in that I'll say that I have to take the minimum number of operations. So I need to find that what is the minimum number of operations that I will take in order to make this remaining value of the ith element as 0. And if I'm not able to do so, then I'll return -1 from there. Okay. So now let's write bool make 0 function. Okay. Now when I write this function, so what are the things that I'm going to pass? I'm going to pass the current element, let's say. Okay. Then I'll pass the remaining number of operations that I have, because see, total number of operations for a particular call is basically mid number of operations, right? I'm checking whether I can do my job in total mid number of operations or not. So if I'm at the ith index of the array, and so far I have done certain number of operations, so the remaining number of operations will be the mid number of total operations minus the operations that I have done. So that will give me the remaining number of operations. And if I can make the element as 0 in the remaining number of operations, then I will return the minimum number of operations required. If I cannot, then I'll return -1. So what I'll do here is I'll pass p here and I'll pass q here. Now what happens is p is my special operation. So I want to take the minimum number of special operations as possible. So what I'll do is I'll say that the lowest that I will take is how much? The lowest that I can take is 0, and the highest number of operations in order to make this ith element remaining ith element as 0 is how much? It will be nothing but the remaining number of operations, right? But I'll try to take the minimum, because see, the lowest number of operations that might be required in order to make this element as 0 or negative might be 0, but the highest that I might get is the remaining number of operations that I have, okay, for this particular iteration. Then after this, what I'll do is I'll say that initially I'll mark my answer as -1, indicating that suppose if it is not possible, so I'll return -1. Now while the low is less than equal to the high, I'll find the mid value. So the mid value will be how much? Mid value you can say will be nothing but, let's say, low plus high minus low divided by 2. This will be the mid value. Now I will check that how much is the damage that I can do, okay, or how much I can get if I'm making mid number of operations here. Let's assume that I'm making this many mid number of operations, and I'm taking mid number of p operations on this element, and the remaining I am taking q operations. So basically I'm saying that if a mid number of p operations I'm taking on this element, and the remaining is how much? Let's say the remaining operations minus what? Minus the mid value. This will give me the leftover operations that for which I can take for which I can use q, okay, because rest of them I can assume that they are being done by the q operation, because I'm assuming that when I'm at the ith element, so on that element, on that remaining element, if I'm applying p number of operations of the first type, then this much will be the value, right? Like p into mid will be the value if I'm applying this much mid. So if by applying this much p number of operations, mid number of p operations, I can make some damage, then remaining I have how many operations left? Remaining operation minus the mid, that is the remaining number of q operations that I can apply on it. Okay, so if the damage that I'm trying to do to it, basically the value that I'm going to subtract from it, if it is greater than equal to that particular element, then I'll say that yes, I can apply these many mid number of p operations and I can do my job. If I can do my job, so I'll say that yes, I'll store this as my answer for now. But what I'll do is I'll search for something better. So I'll mark my high as what? Mid -1, because I want to make the remaining ith element as 0 in the minimum number of operations possible. Because if overall I want to check that in mid number of operations I can make the whole array as 0 or not, so for every element I'll try to optimize and I'll try to take as minimum operations as possible to make it 0. That is what I'm trying to check here. Now otherwise what I'll do is I'll say that my low will be what? My low will be nothing but mid +1 here. Okay, then after that you can simply return the answer indicating the minimum number of operations in order to make this ith remaining element as 0 or negative. If it is not possible, then the answer would be -1. Okay, so basically for every step you are optimizing, because if you want to check overall, what do you want to check? That in mid number of operations whether you are able to do whether you are able to make all the array elements as 0 or not. If you're going to do it in mid number of operations, so for any particular ith element, if you are at any particular ith element, so you have to do it in total mid number of operations. So far you must, like from 0 till I -1th element, you must have taken some operations. That value is updated in done operations. So if you have done certain operations, so that many times q must have been subtracted from the ith element. So the remaining value of the ith element would be how much? AR of I minus q into the done operations, right? So this value of the ith element that is remaining, you want to make it as 0 or negative. And how many operations you have left? Mid is the total number of operations that you could have performed minus the operations that you have done. So that will be the remaining operations that you can perform if you want. So basically, for every ith element, the remaining value of the ith element that you are having, you are trying to find the minimum number of operations or minimum number of moves in which you can make it as 0. So what we are trying to do is we are trying to use as less p operations on it as possible. So that's why we have done what? We are finding our low and assuming that I'm performing so I'm marking my low as 0 here, because for every ith element I have to find the minimum operations for every remaining ith element that is there. That is AR of I minus Q into done operation. I have to minimize the number of operations to make that remaining value as 0. So in that case, I'll say that the lowest operations that I can perform is 0, highest I can perform is remaining operations, but I'll try to use as less as possible. So if I'm giving mid number of P operations on that number, and the remaining the leftover I'm giving as Q operations. So the damage that is being done, if I'm able to generate a value that is greater or equal to that element, so this means I can make it as 0 or negative. So then I'll look for a lesser value. I'll try to see that whether I can make the remaining ith element as 0 in much lesser operations or not. If I can, so I'll return that value. Okay, so basically always I'll keep on storing like this and then we'll return the answer. Now what will happen because of this, always the number of operations that you are doing, you will try to do least number of operations possible. And if it is possible, then that mid will be true and you will store it and then you will look for a lesser value. So this is what we are doing. We are applying binary search inside binary search because you are first of all applying binary search because you have a big range. You can either do 0 operations, maximum you can do is let's say 10 to the power 5. Okay, now you are checking if in mid number of operations your total task can be done or not. Okay, so if assuming that you can do your task in mid number of operations, then you will say that you will store it and then you will search on the left side because you will try to minimize your answer. You will try to minimize the number of operations that you are taking. Otherwise, you will mark your low as what? Mid plus 1. Now, whenever you are at a particular ith element, so far you must have made all the elements from 0 till I minus 1 index as negative or 0. So you must have taken certain operations for that. That is updated in the done operation. So when you come to the ith element, what you do is you subtract it with Q into the done operations, because every time you have done operations before this index, you must have subtracted Q from this particular ith element. So the remaining value of this ith element will be AR of I minus Q into done. Now I want to take minimum number of operations to do what? Minimum number of moves in order to make this remaining value of the ith element as 0 or negative. For that I need to apply binary search, because either I can take 0 operations or I can take remaining this much operations. So I need to take minimum number of P operations that allowed. So for that I'll apply mid. Then I'll check that if I'm applying mid number of P operations, then the value that I'll be able to subtract is P into mid. Then whatever is the remaining operation, suppose if I'm using all of them as well, then remaining minus mid into Q. So let's say the remaining part will be basically subtracting Q from this element again, right? Then in that case, if I apply P number of mid operations on it, and for the remaining sum I again apply Q operations on it, then whatever damage I'm going to do to this element, if I'm going to do equal damage to this element or more, then it will become either 0 or negative. Then I'll say that yes, I can apply this many mid number of P operations and can I optimize them? So I'll search on the left side. Otherwise, I'll search on the right side and I'll return my answer. Okay, so this is what we are doing. I hope you have understood the intuition for it. Let's try and compile it to check if it works fine or not. It's a very good question, to be honest. Okay, it is not working fine for some reason. So let's quickly check this part up. I might have made certain mistakes somewhere. Okay, so let's check this through. So I think basically initially I've marked my answer as 0. That is fine. So see, initially I'm marking my low as this much, then I'm marking my high as 10 to the power 5, then I have my mid value. Then while the low is less than equal to the high, I'm passing the array as well. I hope that I'm not making any changes to the array itself, which I am not. Okay, then what I'm doing here is I have my mid. So mid is basically low plus high minus low by 2. Then I'm checking for this particular mid. Okay, so if it is following the criteria, then I'm marking high as mid minus 1. Otherwise, I'm marking my low as mid plus 1, and in the end, I'm returning the answer. Okay, now when I write this check function, so the done operations is 0. Then Initially I'm iterating, and what I need to do is ith element needs to be subtracted with the q into the done operations, and the number of remaining operations will be what, mid minus the number of operations that I have done. Okay, then I'm passing p and q. If suppose that my moves return 0 -1, indicates that it's not possible, so I'll return false. Otherwise I'll update my done operation with the number of moves and I'll return true here. Okay, so this function is also working fine. Let's check this one. So I'm assuming that I've done same thing here as well, which is correct. So basically my low is this much and high is this much. Let's do one thing. Let's update this as 10 to the power 6, although that will not make any difference. But let's just do this for checking if it is correct or not. Okay. So still on the samples, we are not getting the correct answer because they expect the answer as 4. So somewhere we are making some kind of mistake. Okay. So let us check this again. So let's update this. This is fine, right? Low is less than equal to high. Here also low is less than equal to high. So this seems fine. So I'm getting my mid as what? Low plus high minus low by 2. Answer will be mid, then high will be mid minus 1. Otherwise low will be mid plus 1. That's fine. And we return our answer at the end. Okay. Then what will happen is we'll check. So done operation is basically how much? It is nothing but, let's say, 0 here. Then after that, the number of moves that's required is ith element minus q into the done operation. Then we'll pass what? Mid operations minus the number of done operations, and I'm passing p and q. If it is this, then I'm returning false. Otherwise, in the done operations, I'm adding, and at the end we are returning true. So this does work fine. Let's check this once again. Maybe I can take this as low plus high by 2. So yeah, we update the done operations, and so yeah, I found the mistake here. If the number of done operations right now, if I'll run it, so it was even working for the case of 0. Let's just do one thing. Let's change this to mid and this to mid as well, right? So right now it was not working fine. It is not working fine, but the mistake that I have made is that when will I return true? So if the number of operations that I have done, okay, if it is less than equal to mid number of operations, okay, then I will say that I'll return true. Otherwise I need to return false here. So this is a small check that I forgot to apply. Now let's try and compile this. It should work fine. You can see it's working fine. So I forgot this check, that whatever number of operations I am doing, it should be less than equal to mid. Okay, let's submit this code and it should get accepted now. So yes, now you can see that my code gets accepted. So basically in terms of high, I was taking it as 10 to the power 5. So I was getting some kind of mistake error. Instead of that, what you can understand is that the best operation that you can apply is what? That you can subtract every element by p. So the maximum number of operations will be taken as what? Suppose that if you apply the p operation on every element, okay, so if the first element is there, how many operations you need to apply? ARR of 0 divided by p. Then on the second, how many you need to apply? ARR of 1 divided by p. So total number of maximum operations that you will apply is this much. Okay, and taking the ceil value of it, because if you want to apply 7.2 operations, that's nothing but 8 operations. So that's why we are taking the ceil. This was a small mistake that I was making in my code. We'll attach all the codes in the description. If you have understood this clearly, make sure to comment down understood, and if there's any doubt, you can mention them in the comments. Thank you for watching this video.